This is the second portion that we've done of this. So I will introduce the presenters. I'm Travis Anderson, CPHC, Director of Innovative Design at Placetailor. We also have Colin Schless, CPHC, Lead AP, Vice President from Thornton Tomasetti, and Jay Lee, AIA NOMA, Assistant Director of Design, Construction, Open Spaces at DND. This is actually session number 5. We've had 4 previous sessions. 1 and 2 were held in June. That included attendees with architects, general contractors, engineers, HERS raters, and that was to get stakeholder feedback on the energy modeling and initial results that we gathered. We had another session in August that was focused primarily on developers and CDCs. That was to kind of go back through a cost analysis as well as the modeled results that we acquired. And then this session, 4 and 5, focuses on the guidebook itself. And we're looking for critical feedback on content clarity, what works, what doesn't. We want to make sure that all the information is conveyed clearly and concisely so that everyone understands the direction, because we feel like this is a very important document to get everyone going toward zero net carbon standards. Today's agenda will focus on why are we here. Jay will take that. Section 2, we'll do a little bit of a broad overview of our methodology and kind of key findings. And then section 3, we'll do an overview of the guidebook. In the previous session, we were trying to hold questions and feedback toward the end, but in this case, we'll kind of open up to more questions within section 3. And please use the Q&A icon on the webinar page at the bottom so that they all get filtered into the right place. Yeah, try to avoid using the comments and please use the Q&A. We also really want people to go to the full guidebook. So the link that was provided in the BSA page directs you to there. And there's also, once you arrive there, you can download the full guidebook as well as go to a feedback section where you can type in comments that we're trying to, again, kind of locate everything in one space as we filter through everything, because these comments will potentially make their way back into the guidebook and help influence, what we're going to put out there to the public ultimately. So I'll hand it off to Jay. And why are we here?
All right, thanks, Travis. I also wanted to welcome everybody to this virtual feedback session, and I'm really excited to hear about people's feedback on our study. I particularly want to focus people to focus on the section 3, where we make very particular recommendations in the study. I also want to give a quick overview of how we got here. In 2017, the Mayor Walsh set a goal of Boston being 100% carbon neutral by 2050. And you go to the next slide. The mayor brought together a Green Ribbon Commission to assess strategies to achieve this goal. They had 3 main, you can go to the next slide. They had 3 main strategies that they thought Boston should pursue: reduce demand for energy by increasing efficiency, convert nearly everything that runs on fossil fuels to electricity, and buy 100% clean energy. The next slide. And with that, they felt that any new building that's not net zero will be a building that will have to retrofit in the future. So through the leadership of Chief and Director Sheila Dillon, we've been working with Placetailor and Thornton Tomasetti to study zero emissions in the buildings that we fund. And those are generally the typologies. We have a diverse range of typologies we look at D&D. They're not all large buildings. They range from 1 to 2 family all the way up to multifamily buildings. So we wanted to study best practices, sort of outline optimal strategies, And then this work would then lead to a set of requirements, guidelines for zero emitting buildings, or at least and zero emitting ready buildings. I do want to, so we did get some feedback from some people recently that was very, very helpful. And one clarification I wanted to make is we did ask the consultants to look at electricity as a fuel source based on the recommendations of the our Energy and Environment Department and the Green Ribbon Council. We know that there are challenges to that for certain building types, but that was the goal of the study, just study one fuel type. So with that, I'll turn it back over to Travis and Colin.
All right, so Colin, you want to take section 2 here and go over the methodologies and where we are?
Sure. And, you know, based on some of the feedback from the last stakeholder meeting, I think I talked too much. So I'm going to expedite this section. I'm going to review the methodology briefly. Feel free to ask questions about it, but I'll try to kind of get to some of the highlights of it. Travis, can you skip forward a bunch of slides? Maybe I'll tell you when to stop. Keep on going, 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 keep on going. Almost there. Keep on going. Okay, a little further. Keep on going. Keep on going. Almost there. Ugh, geez, I hit a lot of stuff here that is less critical. Yeah, we can start there. Yeah, that's good. Okay. So what we originally set out to do with this project was to figure out standards for zero carbon buildings, right? And where we started was we looked at 4 individual building typologies, real buildings, actual buildings, real energy models that were used on real projects. And we asked ourselves the question, you know, if you stuck a bunch of PV on these, could these be zero carbon? And we came to this conclusion pretty quickly that little buildings would provide an excess of energy, clean energy, and tall buildings just couldn't get there. And buildings in the middle, as you got bigger, the requirements became more and more stringent. If you go to the next slide. This basically sums it up. You know, if you have the same building with the same amount of roof area, as you get taller and taller and taller, you just can't hit zero carbon anymore. So the result of trying to do this with a bunch of different topologies is you put these really intense standards on bigger buildings, right? So the bigger building you do, the more you need to drop the energy demand per square foot, which just isn't fair. It disincentivizes urbanization, it disincentivizes density. It's not an equitable approach. So if you go to the next slide. Yeah, that sums it up. Next slide. What we came to was a per person metric. So we took all of D&D's upcoming portfolio and we said, if there's a certain amount of renewables on all these rooftops, they could generate, you know, this many kilowatt hours. So that becomes this budget to hit zero carbon across the portfolio. Now, if you take all the people that are going to live in all those buildings and divide that total produced by the total amount of people, you have a budget of kilowatt hours per person, or in carbon terms, a carbon budget per person. Next slide. And so that's where we ended up, this idea of 0.77 tons of CO2 equivalent per person. This lines up almost identically with Passive House's carbon emissions targets. And Passive House actually made the same decision of going to a per person metric so as to not disincentivize density. So next slide. You know, there's the stuff from Passive House from the DOE study. Next slide. But the question is, like, how do you get there, right? So we set this standard of 0.77 tons of CO2 equivalent per person. How do you get there with each building? Next slide. So what we did was we have this kind of hack. We used 4 WFI passive models. Collectively, we have a fair amount of Passive House experience. And we hacked into these models and we got them each to run a ton of different wall U values, window U values, solar heat gain coefficients, all this stuff. And that's what you see on the screen there. Each one of those topologies that you saw there gets about 80,000 simulations. So when we have those 80,000 simulations moving from left to right, you see all these inputs, right? It looks like a whole mess, but each one of those is a series of strings that goes from left to right. And ultimately, based on each one of those combinations, you get CO2 footprint per person. Next slide. So what we did was we took that bar and we slid it down. We said, give me all these combinations that can hit 0.77 tons of CO2 per person, right? And that gave us this formula of windows and walls and whatnot for each of those building topologies. And then Travis has a lot of building experience, same, at Placetailor, about how to do it most cost efficiently. And we selected out the most cost efficient recipes from those. Next slide. And that's effectively what we've come up with in this study, is these kind of prescriptive recipes for how to hit 0.77 tons of CO2 per person in these buildings for different sizes, based on basically the most cost-effective way to do it. And I'll let Travis get into that, but the idea is that it's kind of a cost-neutral exercise. I was just telling these guys, to quote, actually, for whatever it's worth, my father on this one, he said, the intention here is that this is an evolution, not a revolution. And when you see these shifts in these arrows from left to right, there's slightly more stringent inputs on different parameters. And I think that's a lot of what we'd like feedback on today is, how much more stringent these things are. But the intention here is, through this modeling exercise, is that we've created these recipes that if somebody's not doing an energy model, which most projects do not do energy models, they can just follow this recipe and you will end up with a very, very energy efficient building, very, very low operational carbon building. And so, we did a bit of meta-analysis on it, like what sort of window to wall ratios are most cost effective, ventilation. Next slide. To effectively get our formula. So I think that more or less sums up the methodology for how we arrived at these recipes that we have here. There was one question that I wanted to address earlier about whether it was site or source that we were considering. This is carbon emissions, so in effect, it's neither. There's no such thing as kind of site carbon emissions, unless you have like a barbecue grill and you have like smoke coming out of it. I mean, I suppose that's site carbon emissions, but ultimately, all of this is considered from the source. So we use state level multipliers for when you're using electricity at your building from the grid. Now we understand, what are the associated emissions with it. So it's like kind of like source energy, but specific to carbon dioxide emissions. Okay, hopefully that wasn't too brief, but it, again, hopefully leaves enough room for questions if folks have them.
Yeah, why don't we go into section 3 of the guidebook, and if anyone has any questions based on the earlier section, we can kind of jump back and forth as needed. But really, we want the focus to be here on this section. So
let's see here. Hold on. We have a couple questions here. Should I hit them?
Sure.
Okay. It's scary reading the questions before. I've done it offline. Let's do it online. This is a big question. Why create a standard? Is this D&D inventing its own wheel? This is so similar to Passive House, but we're not using that term. Is this just confusing to housing developers and designers? Yeah, that's actually a really important one. So Passive House is a performance-based standard, right? You create an energy model to demonstrate compliance. There's heating load, there's cooling load, heating demand, cooling demand. There's all these things that you need an energy model to produce. Passive House doesn't have a prescriptive standard. They don't have something where a Joe Builder can look at it and say, hey, this is how to get there. So that's effectively what we created. That's actually on Passive House's radar. There's talk of creating a prescriptive standard. The group's not there yet, but we're kind of advancing that. The next one, 1,800 kilowatt hours per person per year goal. FIAS Plus is 3,840 kilowatt hours per person. Is this future goal? I'm not sure what that means, but the emissions that we're setting per person, should there, we'll have to dive into that one. If you want to send me an email on that one, that's fine. I want to I want to hold off before I answer it. Does 1800 kilowatt hours include plug loads? Maybe, if we have a second, can we go back to where it says 1800 kilowatt hours? Maybe I can help
Sure.
answer that one, because that doesn't sound quite right. I think, oh, okay. I get it. Okay, this is, I believe this is, that's, okay. I believe that's a site EUI number that's on there. We should just get rid of that altogether. It's quite confusing. Passive House has primary energy numbers, which would be, 2.8 plus that.
Yeah.
But you know what, that actually may be a dated figure on there. For the purposes of this exercise, let's strike that and keep with 0.77 tons of CO2 per person. And if you want to talk about the math of how we get there per person, totally into that.
Yeah, because this also is contingent on if the grid was to be cleaner too. So, we wanted to present this as a method to get there now. We're not looking at future clean grid. So I think, certain multiplier, yeah, we'll have to kind of get back into that data a little bit to.
We can dig it. Yeah, if you have numbers questions, I love getting those by email. So please send them. Does Article 37 still apply? Jay, we talked about that earlier. Yes, Article 37 still applies for buildings of a certain scale. Why was solar not treated as an ECM similar to others? So all these numbers, the budget was based on a fixed amount of solar on the buildings, and then the energy use comes after that. So, you're saying, like, if a project wanted to increase the amount of solar production on its roof, would that be considered? That seems to be the only way that you would do that. Again, this is the portfolio-wide approach. It's not a variable that you'd manipulate on a portfolio-wide approach. We kind of felt like we maxed it out on a portfolio to achieve zero carbon. The standards are the kind of the numerator on that. Will you allow Passive House certification as an alternative pathway to prescriptive measures? We talked about that a bit too. A bit of this is still kind of getting resolved. Wow, questions are coming in fast. That's good. This is currently intended, primarily we're focusing on the smaller building topologies. We imagine there may be some more flexibility for the larger topologies, is my understanding. But it sounds like Passive House certification would likely show compliance with this. It would probably be consistent with it. Does 0.77 include plug loads? Yes, it does. It's hard to make electric domestic hot water work in a multifamily because gas is so cheap. Yeah, we've had that question a few times. We've been able to show that it's actually, there isn't a operational cost increase. If you use a heat pump, which we're recommending, you actually save money. Are the winter wall ratios lower than what we see new buildings generally are in the market? Yes. 1800 is site, you should keep it. Please explain a site versus source values from Passive House. Agreed. We're trying to move away from energy metrics here, just focus on carbon. High-rise buildings can be made to be Passive House. I don't think you should discount energy efficient high-rises. Nope, not discounting them. This is a way for high-rises to achieve the same standard. Stretch code and or Article 37 would require some form of energy modeling. No. Yeah, so again, once we get into the bigger building topologies, Article 37 would require some sort of energy modeling. I think we probably need to work a little bit on alignment with that. But in either way, if you're following these standards, there would be no issue hitting that. Hopefully this won't be a requirement since affordable housing can get QAP points, utility incentives funding. I'll defer to Jay on that one. And the last one, your modeling summary does not show anything for cooling. Why not? In terms of cooling energy use, we should have some cooling energy use in there. The buildings had cooling.
Yeah, we were considering the cooling as part of the heat pump.
Yeah. Okay, I think I got through those. And again, oh crap, there's more. Excuse.
Yeah.
I feel like I should hold off for a minute.
Yeah, why don't we hold off for a minute and we'll kind of get maybe a little bit more into the meat of the document. I just kind of wanted to hold off here. The previous section was showing how we arrived using the methodology, and then we get more into building cost analysis and how we started to arrive there. Couple of questions that we received after the last session was about going into this deeper. So we will provide a little bit more of the back-end analysis as part of an appendix, so people can see a bit of a further breakdown there. We by no means want to make any of this too opaque, so that's a big point of this. And I just wanted to kind of highlight here that, you know, a lot of folks in the high performance building world know that air tightness is kind of a key factor to all this. And one of the almost not necessarily a major cost driver, but where we did see air tightness becoming more of a factor was less about the materials and equipment needed, because if you read the code as it is currently written, a lot of that just needs to be purchased to hit the code requirement anyway. So where we saw a major breakpoint was kind of in the management level and training level. So as building teams get more familiar with doing airtight buildings, you know, this might even drive the cost parity down even further. So, you know, once middle management and QA/QC come up to speed with airtightness, you know, we see this as a good factor and good indicator that the construction industry will move in a more effective manner to deliver these buildings. So just to further breakdown of what we analyzed, this all corresponds back to anything that we're going to recommend and the recommendations breakdown in the summaries. So heat recovery, ventilation, heating systems, overall wall values, roof values, floor values, and going back to the domestic hot water systems, there has been a lot of chatter around these as well in the high performance building world, just the shift to air source heat pumps. We do recognize that this is a emerging technology here in the States. There are a lot of systems that have been proven in Europe and Japan for a number of years, and we're hoping that those will come across the shores soon. And we've also seen studies coming out of New York City that are showing larger multifamily buildings taking advantage of air source or water source heat pumps in a very effective manner. So if people are looking for case studies on those, we can provide a resource guide in the back of this book to direct people in that direction. We've seen some stuff coming out of Steve Winter that in New York for some of the buildings that they're working on. And Colin probably has a little bit more input there as well.
Yeah,
what he's been seeing too.
Just the quick math on it, and again, please, we welcome feedback as everything moves towards electrification. This is obviously an issue that comes up, at least on every project that we work on. But at a very high level, electricity per BTU is about 3 times the cost of gas. But a heat pump is at least 3 times as efficient as a natural gas hot water heater. So we see this, starting to neutralize the cost, if not create some savings, if the COP of your domestic hot water heat pump is even higher. Electric resistance obviously is more expensive, but we're seeing operationally the cost being quite competitive.
So after we summarize what building elements we did on a cost per basis, we tie the two together in terms of energy and cost and do a comparative chart looking at stretch code versus the zero emission building and either the percent decrease overall in either direction or increase in terms of cost. So I think it's important for people to take a closer look at this table. Maybe if we want to hold here and answer some questions around it, but this is we want to make sure this comes across clear and address any questions that people may have about it in terms of, gleaning the right information out of it. So I don't know, Colin, if you're seeing any questions specific to this one, but.
Hey, Travis.
Yeah.
I just, this is Jay. I wanted to ask people who are on the call with a virtual session here, when you have questions, could you be as specific as possible about the type of building you're talking about? And as we get into section 3, we actually went through, as you can see in this slide, there's 4 different typologies. We understand that there's some things that aren't possible or might be difficult in certain typologies, but if you can be specific about what you're talking about in terms of the building type and maybe how it applies to the recommendations that we're talking about, that would be really helpful for us.
Travis, maybe I can address, there seems to be kind of continual questions about passive house that I'd also like to kind of hit that really quick, because we have talked about that quite a bit, and we talked about that with Jay, and it's an important topic to make sure that we're not viewing as like antagonistic with the progress that that group has made, which is incredible, by the way. With these standards, any project can still certify under passive house. That's not a problem, and you would still apply for all the mass save incentives, which we'd readily encourage you to do. I mean, basically, if you follow the D&D standard, you're basically there already. Like you're basically achieving passive house. So if a project wants to move forward and apply for those incentives and get those rebates, then like more power to you. You'll probably end up saving money on your project. It probably makes a lot of sense. It's not necessarily under the D&D's purview to do that, to encourage it in that direction. So these are not conflicting at all. This is basically addressing projects that are not, that maybe don't know about passive house, that aren't pursuing that. But folks are more than welcome to address it, to pursue passive house. But then that's a high level question to Jay's point. If you do have specific, kind of building science and envelope questions, please, say which one of these topologies you're referring to. Oh, okay. So we have a few more questions lined up here, and I'll just start going through them. Jay or Travis, feel free to cut me off if I'm going too far through these. I know we have a certain amount of time. D&D occupant criteria for plug loads says 2 people per bedroom, but passive house criteria for FIAS is occupant load is bedroom plus 1. Yeah, that's a great point. That's a great eye. Whoever wrote that really knows their stuff. So we talked about that quite a bit. D&D buildings typically end up with higher occupancy than a lot of projects that we look at. Jay was saying, looking at surveys across their portfolio, there's higher density of people in them. So that's what we plan for in terms of that budget. My guess is that probably factored into the budget, which is why that kilowatt hours looks lower too. So for the same building, we're assuming a higher occupancy per building than passive house would. Therefore, the budget for CO2 emissions goes down, if that makes any sense to you. Right? Same building, more people. If your budget's per person, that budget goes down when you've got more people in there. You've got, so if that makes sense. That's a really insightful point though. Great note there. Will air tightness be measured? Thermal bridge avoidance inspected? On-site stuff, we got to talk about that. It's a very good point. I mean, a lot of this passive house and kind of nature of things is dependent on a very airtight building. So what sort of QA, QC things are required? So we'll talk about that a little bit more.
That will probably be a part of our requirements, a process for inspection and verification, especially the airtightness.
Airtightness metric unit is a bit confusing comparing CFM 50 and CM 50 gross exterior SF. Okay, so we'll clarify the airtightness requirements. We did want those to be in line with passive house. Okay, yeah, another good note about mass save incentives. Yes, we're encouraging, projects should apply for that. No reason not to. It'll save you a bunch of money. Air source heat pump domestic hot water systems are proven technology, but also proven too expensive in our market for affordable housing. Again, we were asked to be a little bit more transparent about the costing on this stuff. We're seeing that that's not the case necessarily. There's also incentives here in the state for heat pump hot water heaters. I took advantage of them for the heat pump that's sitting underneath me right now in our basement. And it neutralized the cost between an electric resistance water heater and a heat pump hot water heater. Like literally same exact cost.
Yeah, and one more thing on the domestic hot water front. We also look at this as a little bit of a design challenge in the larger buildings where you might want to do more of a centralized system. So looking at ways to do a semi-centralized system, or the ability to potentially even convert a fossil fuel based system over to a heat pump system to electrification, if the right low temp hydronic system is in place. So there's strategies in which you can do hot water, and there's many avenues you can go down, and it's definitely the nut to crack in terms of the larger typologies. Once you get into maybe the 3-story smaller multifamily realm, those typologies, the heat pump hot water is much more easier to contain because you can almost do it on a per unit basis. And there's even a guide that Eversource put out in 2018 about kind of best practice strategies to do single unit, unit to unit heat pump hot water systems that, again, we can put that in a resource guide in the back. So we do understand the challenges that folks are going to face with heat pump hot water. But again, like Colin said earlier, think of this as sort of the next evolution that we're going to have to undertake. So it's just if we all work together, we will get there.
Let's see. Why does the unit count only go up by 1 in the 4 to 5 and 6 story? We could dig into a little bit of that. There's a chance it could be a typo. I don't have it fresh in my mind. But the other thing is that these are real buildings that we were using. So it's not like we were normalizing the square footage per apartment. It wasn't in the scope of this to like design a perfect multifamily so these sizes align identically. That would have been actually a really interesting exercise, but again, we were kind of using what we had. So that could also be part of it.
Section 3 are actual buildings. Just there.
Has the heat pump hot water 2.1 COP been approved in Mass? What's the cost change compared to gas? I'm not sure what you mean by has it been approved. I don't know how to answer that question. I mean, you can go to Home Depot and buy one of these things with a COP higher than 2.1 and put it in your house, and it is very much so approved and also encouraged by the state. I don't know if that helps. COP also means coefficient of performance. That means the efficiency of it. So 2.1 COP would be a 210% efficient unit, in case the acronym was misunderstood. Hank has a question, 6-story, 51 units. Again, I can look into the topologies if that's helpful.
Yeah, it also might help to clarify that we left commercial space out of the modeling. So if it's potentially maybe the 6-story, we'd have to go back and look at that building in particular, but maybe there was a story and a half of commercial space or something in there that we removed out. Right. And to Colin's point, we didn't. Some of these buildings were close to D&D's guidelines as far as unit sizes. We tried to find building typologies that kind of fell within those parameters. But again, it could be that some of the units were just a little bit bigger than what's typical for D&D too. So maybe I'll kind of scroll down a little bit further and just kind of get into this part of best practices where, again, going back to earlier comments, this is really to kind of set the path for people that don't have access to energy modeling, that might be new to high performance buildings, and kind of give that simple approach on how to get there. At Placetailor, we get those questions a lot from other builders and new developers. We function mostly in the private market, so you know, this is something that they're interested in, which is great to see, you know, the market moving in that direction from our standpoint. And then as far as affordable housing is concerned, you know, there are other folks that are operating in that sphere at a smaller scale too, and it's important for them to kind of gauge an understanding on how to get there. So this is really kind of setting up kind of architecture 101 in terms of a zero emission building and the priorities that we see that it needs to take on. So thermal bridge free construction, it would be airtight, as we talked about, all electric with heat exchange ventilation, on-site renewable energy generation. We encourage evaluation of embodied carbon in all materials. We have a little bit of in the resources, we'll add some ways to access any of the guidelines for embodied carbon. Also, we can direct people to the Carbon Leadership Forum and some free tools that are available there. And then also we want to, this includes, can include offsite renewable energy as necessary and carbon offsets as necessary. So if you can't get it with the 75% roof area, you know, you can go down that path as well. And also there's a note here about the D&D's secondary approach to a zero emission ready building. So that's another avenue in which, you know, D&D is looking at as far as a zero emission ready is concerned. So it might not have the PV, but the potential is there. So key strategies, again, architecture 101, surface to volume ratio is what we're encouraging. Kind of the more push and pull, the harder it's going to get to achieve these. Also keep in mind that when we're looking at cost, we're looking at a simple zero emission building. The more complicated you get, you can get into structural systems that are more complex and more expensive. So we don't want these typologies to sort of be singular, and we encourage architectural expression, but that's sort of the challenge for the design teams. So, you know, architects enjoy having constraints. So working within a simplistic constraint could be a good thing. Orientation, we know that these are urban infill. So the typologies that we looked at, you know, they might not have the optimal solar orientation, which is why, again, we wanted to model real buildings. Going back to unit density, the carbon metric per person encourages density. You know, we want to ensure that the urban fabric is fulfilled, and we see that the path towards a better carbon future is through densification in the urban centers. Glazing percentages, again, we're looking at that kind of 15 to 18, maybe 20% range of window to wall ratio. Kind of your path to getting to a thermal bridge free assembly. Best ways to achieve air tightness, and kind of following the red line principle. So the more squiggly that red line gets, the more challenging the air sealing will become. And then a good balanced ventilation system with heat recovery. We want to encourage that as well, as indoor air quality is becoming even more important, especially with what we're all facing right now. There's been some early analysis on particulate matter and how that contributes to virus spread, which has been pretty interesting. So again, you know, we can start using buildings as a means to help fight our current pandemic we're in. And then also just
sorry, you're just talking about natural gas there, and there was a good comment that brought up, but I'm trying to figure out how to use these toggles to answer it. I failed. But the question was the avoided infrastructure for natural gas factored into the cost of the all-electric building? Was there like an avoided cost that we considered?
Yeah, we did look at that as an avoided cost. Yep. So eliminating that street connection, especially in new construction. You know, it's one less opening you have to do in the street, and one less utility you have to bring in. And then just going back to kind of the general zero emission assemblies and how to achieve that. again, if, as we've mentioned a few times, if people want to go beyond this as a methodology, as a means to have a better performing building, you certainly can do so. But these are minimums, so we just want to make sure that you know, it's accessible to the people that may be a little scared of energy modeling or going down this path. And the idea is to show that it is a simple way to go in terms of building construction.
Yeah, and there was a good question, actually a construction question that said, what if some passive house analysis indicates that a different wall design is preferable? And I think there's very much so that's encouraged. The idea was, if somebody looks at this and they see R30 wall and they fall off their chair, the idea is that this is a way that Placetailor found to build it cost effectively. And I just said R30. I don't remember what we actually listed in there off the top of my head. But of course, but again, it's a performance value. So it's the cumulative R value of the wall. You can make out of mushrooms if you can show that if you can show that it works.
Yeah, and going back to the wall assemblies, we've found in the smaller typology, the double stud wall is a really good cost-effective way to go. It's easy for stick framers to get their head around. They're just framing the building twice. There's a lot of debate, I know, in the world about the worries about condensation and permeability. But as long as you have the right vapor barriers to the inside, you feel like you'll be okay in the smaller typologies. And certainly in the larger typologies, you can look at how to achieve the overall wall value. Our value in the wall maybe probably wouldn't be through a double stud, but there are certainly more cost efficient ways to get there. And then just one quick point, just to also for a reference, there's a new article out in Fine Home Building for the smaller builders that might be out there about the effectiveness of double stud walls and how cost efficient they are. So it's some nice reading during the quarantine if you feel like it.
While we're on the topic of walls, a question was brought up that says that minimums of R36 to R46 walls will often produce overheating in passive house buildings. I don't agree with that. I do agree that overheating in very tight, high performance buildings is an issue. It has been, especially since the rise of passive house for a while. We're finding that the window properties have more of an influence on overheating, and the size of windows have more of an influence on overheating than do the R value of the walls. If you think about a multifamily building, each unit only has effectively one exterior wall. You're looking at a relatively low percentage of the overall envelope exposure. So the R value of the wall, especially in cooling season, has very little impact on heating. Again, also if you look at I'm getting a little building sciencey here, but R value of walls mainly affects the heating period. So when it's 0 degrees out and you're trying to maintain 70 degrees inside your building, you've got a 70 degree delta T. When it's 80 degrees outside and you're trying to keep it 70 degrees inside, you have a 10 degree delta T. The insulation in our walls is dealing with that delta T. That's the only thing it sees, right? It's not seeing solar gains and stuff like that. So the actual insulation value of the walls won't affect cooling as much as your window properties do. A high solar heat gain glass, which was historically a problem with passive houses, creates these solar cookers. It's like old school solar design. Very aware of that issue. We're consciously limiting solar heat gain coefficient on windows and minimizing window to wall ratio to try to reduce the potential for overheating. Also encouraging operable windows. Well, encouraging it's required, but anyways, I just wanted to hit that one quickly. And then there's a question about emergency power, which is a very relevant question. Happens on every all electric building. We are not saying you need to do battery storage for these projects. Emergency power may need to be fossil fuel based. The reality is when power goes out, we need reliable backup solutions. We haven't kind of created requirements about that yet, but I can say based on a lot of the quote unquote decarbonized buildings we've worked on, many of them have still included fossil fuel emergency power for very practical purposes.
Yeah, I think it's important as we look at the modeled assemblies here. Since we were looking at real live buildings, everything that was modeled in the background was actual product that's available on market today. We withheld the information, but the manufacturer information. But we do want to point out that these are real assemblies, windows, heating systems. So that's something we can figure out how to represent in the resources in the back that'll end up in the appendix in the book. So I just wanted to point that out. And also in the energy modeling, as Colin mentioned, when we did the parametric analysis, we were sitting there and scrutinizing the outputs pretty significantly in terms of what a comfortable building would be. We certainly could have made these buildings very uncomfortable for the occupants if we weren't considering solar heat gain coefficients and the window to wall ratios like Colin was saying. It was important to us that these were occupiable and comfortable buildings too. So that's what this criteria is also looking at. So again, I'm just kind of going through one of the real life case studies here, so of what the modeled assemblies actually were. This is looking at the massing, and it kind of relates back to the initial best practice study. So again, you can see it's a pretty simple building.
Looks like there's another comment about, again, cooling is definitely an issue. What about interior heat gains from lots of residents? Yeah, of course. We're seeing with these dense topologies, there are internally load driven a lot of the time. But again, we haven't found that the conductivity of your wall is a major influencer on heat regulation in those spaces. Again, we found that it's the supplemental gains from the sun that will tip you over the edge. But yes, interior heat gains from lots of residents is going to be an issue in any one of these buildings that, other than limiting the amount of people you have inside, architecture won't necessarily solve. And I'm not convinced that a lower R value wall will solve that either.
Yeah, and I think that comes also down to sizing your systems appropriately. So where we are climate-wise, we're kind of in between the heating and cooling demand. And as we get into more high-performance buildings in this climate zone, we start to see that heating actually has, cooling actually has a higher need. So sizing the systems appropriately starts to get a little tricky in terms of how you're sizing your heat pump systems or heating and cooling systems. So that's something that it's important to pay attention to, and also future look too. Like, we know climate change is occurring, so dominant cooling probably will become more and more of an issue. So it goes back to system sizing appropriately too, to have it comfortable for the occupants.
There's a question here actually that kind of addressed what you're talking about. It says, did you test these for future climate conditions? Which is an excellent question. So when we look ahead to like 2050 and 2080 weather files, which we have some fun with sometimes with there's the WeatherGen tool. I don't know if you guys have played around with that, but it's really cool. It kind of tells you what to see based on some of the predicted temperature rises. We're seeing about a 3 to 4 degrees rise in the next 30 years, and another 3 to 4 degrees rise in the next 60 years. And we did not test those future conditions. That 3 degrees rise will also be coupled with increased heat waves, which will stress all buildings, not just these buildings. and that wasn't part of this particular study. I know somebody at Berkeley that's looking into like how to model those future heat waves. It's a really interesting study. It's also a very difficult thing to study because you're not looking at trends, you're looking at these anomalies. But you know, that making kind of a resilient building for heat waves is certainly an interesting consideration. We are including mechanical cooling in these projects, which you know, if we were going for a naturally ventilated building, I think would be more of a concern, but which isn't to diminish those concerns. I think it's relevant.
So maybe here we can kind of keep peeling through the Q&A. Sorry, we're jumping around quite a bit, but we're trying to address as many as comments as we can. We have about 5 minutes left. So maybe if there's anything we want to reference back to, anything specific, we could kind of maybe tackle a couple questions in regards to that.
Travis?
Yep.
It's Jay. Before we were starting this seminar, we were chatting, and I think Colin, we were talking to your dad. You were saying that this is sort of more like evolution, not revolution. And so we're trying to improve practice through the guidelines and the requirements that we're creating at D&D. So I really do appreciate all the feedback. So our goal is not to sort of take over the industry in any way to plant passive house or anything. We have a lot of buildings that don't do any energy, do very little energy efficiency at all, much less carbon emissions or think about the environment at all. So this is a goal, again, aligned with the mayor's vision of the city being carbon neutral by 2050. So I think we're all on the same page about climate change and improving the environment. So that's the spirit in which these guidelines will be, and the requirements will be intended. So definitely, please ask more questions. We look forward to your feedback, okay?
Thanks, Jay. Anything else that's jumping out to you, Colin, right now? Or?
Travis, could you also, there's a few areas where we thought they would have the biggest impact.
Yep.
Like air
tightness
and infiltration. Could you go over some of those things we thought would have the biggest impact in the study?
Yeah, so it actually, we anything in red in the study in terms of recommendations are areas that we wanted to highlight as a little bit more critical in terms of what the standard could be. Air tightness being one, window U value being the other. And again, going back to the window to wall ratio, we kind of saw those three as kind of major criteria. Not that the others shouldn't be followed or adhered to, but we saw this kind of as a easier path to get to reach the zero emission standard. You know, finding and sourcing heat pumps, those will come down to working with your MEP or even if you're doing design build, your mechanical contractor. And then window, roof, or wall, roof, and floor R values. You know, again, as Colin was mentioning, those can be achieved in a multitude of ways. So what we were trying to highlight was, you know, key assemblies. You could take these wall sections and implement them and hit the effective wall, roof, and floor R values appropriately. And also showing, you know, how you can kind of trace that red line, that red air barrier. So making the connection from foundation up to roof appropriately and effectively. So I think that's, as you go through the booklet, anytime you see anything kind of bold or brought forward in red, that means that we're seeing it as an important feature to the building typologies. So Colin, I think we might have lost your audio.
Oh, shoot. Yeah, that was my fault. Sorry. Like I'm on my like 10,000th the Zoom, as most people are, and I feel like I should have the hang of it by now. So apologies. Um, one piece of helpful feedback would be to practitioners out there, or I guess everybody, is like, what are the requirements to make you fall off your chair, right? This is supposed to be an interactive process, and we're definitely taking notes about what people have to say. So from the practicality standpoint, it sounds like, electric domestic hot water was a big one that people flagged, especially in larger buildings. They're worried about doing it. I think that's an equipment issue that we need to kind of get our heads around. I'm less concerned about operational costs, again, because the numbers suggest that there isn't a huge operational penalty. That seems to be a big one. There were some comments about overheating that I think are worthy of addressing. I think that's true for, all passive building. So that should be considered. I'm surprised there weren't more comments about the ability to achieve the level of air tightness that we have on there. To me, that's one of the bigger flags. I think the industry can get there relatively easily, but from contractor experience, folks we don't have a giant workforce that's familiar with airtight building. It's not a huge stretch to get there. But currently, at least I'm not seeing it, other than some folks that really know what they're doing. But anyways, long story short is, if you guys want to submit the kind of fall off your chair things, that's really helpful for us to boil down and make these as practical as possible.
Yeah, that's a good point. And then here we're highlighting a couple, some questions back to our audience. So we'll share the slide deck, but you can take a screenshot of this and go back to either put it in the Q&A here, maybe if you have a response now, or you can go back to the feedback session on D&D's website and maybe enter an answer there in terms of these questions, and making sure that everything's coming across clearly in the guidebook.
Also, I think I want to make sure that there is going to be a difference between this study and the guidebook and what we ultimately have for requirements, D&D requirements. There'll be a separate document that we're going to actually put out that actually defines what we're going to use for requirements. So Travis and Colin's point of, if you can really focus in on things that are fall off your chair. We already heard that for larger buildings, domestic water heating will be challenging. So there's some things we are in agreement with some of the comments that have been made in the Q&A. I also understand I want people to also think about the fact that the building code, stretch code are going to increase even as we're speaking, sort of. So some of the things that are shown, especially in the wall assembly and floor and ceiling assembly, are going to get higher or more stringent automatically. So I just want people to, if you can, focus in on things that we know that we want to, like, especially the air tightness that Colin just talked about, how to actually achieve that in construction. If there needs to be inspection, things like that. Any kind of insight you have from your existing projects would be helpful as we start to make actual requirements.
All right, well, it looks like we're a few minutes over on time. I think that's probably a good spot to conclude. Thanks everybody for joining us. Thanks to the BSA for hosting us. D&D, BPDA, Department of the Environment, everybody involved, Thornton Tomasetti. Yeah, this is a shared endeavor. So again, the more constructive feedback that we can get, the better for a document like this, so we can really put it out there and make sure we make the world a better place.
Yeah, we've got thick skin, so
Yeah, Colin and I have been beat up many times in front of an audience, so we can handle it.
I do want to thank Colin and Travis and the BSA and John Delzell at BPDA and Allison at the Environment for sticking with us for a lot longer than we probably planned originally for this study to take and will take. I'm personally very proud to be one of the few cities in the country probably who are actually taking a study like this. So I'm very proud of the team we put together and the work they've done. And I think that the administration appreciates it as well. So thanks, guys.
Thank you.